Okay, we're live now. All right. So this is day
All right.
4 of Jeff and Dom versus Advent of Code 2025. We're streaming every day for the next 8 days from 7 to 9 p.m. Pacific. With some asterisks to that, we are actually not going to be doing a stream tomorrow and the next day, and we'll be doing a long stream on Sunday. One thing you'll notice is that to my left, to my right, I think technically it's to my left, based on the stream. We have a guest host today. It's my friend Saman, who is my buddy in the East Bay game dev scene. He's sitting in for Dom tonight. And I believe this is your first Advent of Code experience. Is that right?
Yeah. I mean, I've written a lot of code in my life, but I'm not like a programming puzzle person normally. So we'll see how it goes.
Okay. I think it should be pretty chill, pretty fun. And there's no real preparation needed here. Hopefully, when we are done with the programming tonight, we can switch over and talk a little bit about some things. I want to talk about the games that Salmon has worked on, but we also want to talk about multiplayer games. That's sort of the talking point about video games tonight. So with that said, should we get into the problem?
All right.
Cool. All right, so I'm going to go ahead and kick it off. We're going into day 4, printing department. So, Salmon, if this is your first time dealing with Advent of Code, you'll notice that there's going to be this kind of like funny story about elves. There's like kind of like lore for all of these puzzles. It's typically not that important. It sort of adds color, and it's a little corny, but it's fun. Anyways, here we go. You ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere, and there's even a massive printer in the corner to handle really big print jobs. Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that, one of the elves replies when you ask for help. We're pretty sure there's a cafeteria on the other side of the back wall. If we could break through that wall, you'll be able to keep moving. It's too bad all of our forklifts are busy moving these big rolls of paper around. If you can optimize the work the forklifts are doing, maybe they would have time to spare to break through the wall. The rolls of paper are arranged on a large grid. The elves even have a helpful diagram, your puzzle input, indicating where everything is located. So for example, all right, so there's this square here with a bunch of periods and a bunch of @ signs. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. If you can figure out which rolls of paper the forklifts can access, they'll spend less time looking and more time breaking down the wall to the cafeteria. So in this example, there are 13 rolls of paper that can be accessed by a forklift marked with X. So they kind of are marking what the answer is supposed to look like here. Consider your complete diagram of the paper roll locations. How many rolls of paper can be accessed by a forklift? Okay, so Salmon, does that question make sense to you?
All right. So we have these grids with @ signs and dots.
Mm-hmm.
They represent. What is a row in this metaphor? I'm not sure, but each row is being processed by a forklift.
Yeah, I think this is like a this is like a top down. This is like a top down map of the floor, and basically a roll of paper is an @ sign, and if there are fewer than 4 rolls of paper in the 8 adjacent locations, so that's like north, south, east, west, and also northeast, northwest, southeast, and southwest. If there are 4 or fewer in the adjacent locations, then they can move it, right? So as an example, this first one here, basically it's the 3rd column in the 1st row. There are 1, 2, 3 other rolls in the adjacent location, so that one counts, right? And then one that doesn't count is like this second to last one in the 1st row, because there are 1, 2, 3, 4.
Fewer than 4.
Oh, fewer than 4. So it's got to be less than 4. Okay, got it. Nice. Okay, so I think at least for this part of the problem, it should be relatively straightforward, I want to say. Did you ever make the game of life? Do you know what that is?
Yeah, I mean, I kind of understand how you would start to do some of this stuff. I don't think I have a full grasp of what the actual problem we're solving is right now, though.
Right. So, well, the actual answer that we're trying to go for,
Let me reread this one more time.
yeah, we're just trying to answer how many roles have basically 3 or fewer neighbors. So the idea is that we're probably just gonna like iterate over every time we find a role.
Okay, okay. This is pretty straightforward.
Yeah, I think it's pretty straightforward.
Yeah. Okay.
Cool.
Sure.
Okay, so
and then this example is just a random example. So we're just writing a function that can take any floor plan, right?
Yeah, exactly. So we'll go ahead and just to give you an idea of what's going on. Basically, we have a function called example that'll give us every line as a string, and we want to parse that into a representation that we can better solve the problem with. So I'm actually just thinking it's like an array of Booleans, and it's false in a particular cell if there's no role there, and it's true if there is a role there. How does that feel to you? Or we could just do the characters too.
Sure. Yeah. I mean, we can do that works fine. Yeah. So first step is we just parse it into a 2-dimensional array.
Yeah, exactly. So lines is an array of strings. Sure. So basically, we're gonna convert this into this is the first string, this is the second string, this is the third string, and so on and so forth. Right.
It's already an array of strings. That part is already done.
That part, that's just like utility. That's like a utility function that I've written to help do these problems, because literally every single one of these problems involves breaking up an input into that. So we'll go ahead and include that here. And if you actually want to look up the definition of this, you can navigate in my text editor. You can kind of you can poke around if you want to.
Yeah.
But what I mean.
So the neighbors that we care about, it's
right.
Sorry, should I not be doing things while you're doing things?
No, you theoretically can. It kind of works. It works sort of shockingly well.
Or are we trying to do this as fast as possible, or is this more like?
I think there are people who do this competitively.
Time, enjoy ourselves.
Yeah, there used to be like a global leaderboard for this.
Yeah.
But I've never tried to. I've never tried to do it that quickly.
Yeah.
You're listing out all of the
does the self count?
The self does not count. No.
Yeah, the directions, right?
Yeah.
Yeah. Okay. So it's 4. We got that one, that one, that one. 0, -1, 0, and then it's going to be the next line, which would be 0, 0.
Yeah, I think you're if you're enumerating all the directions, there's probably 2 more. There should be a total of 8, I think.
Yeah, right. 2, 2, 2, 2. And then 0, 0 is the self, right? And then you got the 0, comma. We already have 0, 1. Wait. Directly above. -1, 0. No, 0, -1 is directly above.
Right.
Directly to the right. -1, 0. -1, 0. Am I missing a direction?
No, I think you've
so.
got
1, 2,
it.
3, 4, 5, 6, 7, 8. Right?
There should be 8. So I think what you want, like, there's like going to be -1, -1,
1.
1,
Yeah, -1, 1.
and then
Yeah, and then
1,
1,
0,
-1. Yeah.
and then. Oh wait, you already have -1 here. I'm trying to figure out what the.
I think we got them now, right?
Yes.
Yeah.
Okay. There should be 8 of those, right? Okay, so what I did is I set up a loop here. And basically what this is doing is we're going to iterate over every row in the grid and then every column in that row.
Yeah.
And then we're just going to check all of the neighbors, right? So it's something like for constant n of neighbors, we're going, and then it's actually going to be like the delta of x and the delta of y. Right. Yeah, I think the count actually needs to be out here if you're talking about the total, because it'll be like we're counting over the entire grid, right? So what we'll do is we'll do j,
right.
We'll do x equals j plus dx, and then y equals I plus dy. And then if either of these are negative, we know that we're like outside of the grid. Is that right? So we can skip. Right. So for example, if we're like in the very first one and we look like north of there, we're off the grid, right? So we should skip that one.
Yep.
Nice. Look at that, teamwork. And then so, you know what? I see what you were saying. The count does go here. I see exactly what you're saying. Sorry about that. So basically, we're just saying if the grid of...
We need both, eventually.
Yeah, you're right. Y and X, if it's true, then we increment count, right? And then we'll have a result at the end that we'll have over here. And then once we're done counting over the neighbors, we're just going to say if count is less than 4, then we increment the result, right? Mm-hmm. And then I think we should just be able to just like log the result here. And then we'll just run this and see what happens. Cannot read properties of undefined. Reading 0.
Wait. Grid? What's our grid? Is our grid looking the way we want it to?
Yeah, let's go ahead and log that. Okay, so that's the grid right here. False, false, true, true, false.
My like buffer, and my buffer in my terminal is like tiny. Oh, there it is. No, I just have to scroll down. Okay.
Yeah. So I think this is parsing correctly.
All right, well, I don't think that's the issue. We just must be overflowing.
Yeah.
We're overflowing somewhere. Right?
So.
Yeah.
Is J?
Well, if they're greater than the max, right?
Oh yeah, we have to make sure we're not going over the left side or the bottom side. Yeah. So we're saying if or grid or row dot length. If x or like row dot length is less than or equal to x, or grid dot length is less than or equal to y, that should cover the going off the other end. All right, so if we run it again, we get 22, which is too many actually. I think that the answer is supposed to be 13 with this example. Is that what they said?
In this example, there are 13 rolls of paper that can be accessed. Are we counting the opposite? Are we counting count as less than 4? No, we're not. We're doing that correctly.
Yeah.
That's
I'm
less
going to
than
rearrange
4.
these real quick just so I can see them better.
Yeah.
And then I think we have two of the same thing in here. That must be it.
I was gonna go.
Well, this is 1, -1.
Okay,
I think. Yeah,
good. I was going
what it is.
clockwise from left and around, but then I got distracted.
It's cool. Okay, so I made that one line change. We'll see what happens. Okay, so it's 19. So that's still not quite correct.
Interesting.
Yeah.
Interesting. Yeah.
Let me just double check this. Yeah, and the only one that we don't have in here is 0 and 0, right? So that seems like it should be correct, right?
Yeah.
We could just print out what we could print out, like every single one that increments it. We could just say console.log.
Wait, in this example below, I'm going to look at the example. I want to see where the X's are marked here.
Yeah. Oh, we've got a couple of folks in chat. Sorry, I had the window slightly. I had the window in the background. Dom is usually really good at like watching the chat. But hello, Nathaniel Bumpo, and hello, Acrobatic Fish. Thank you for the hints here. You can include the self count if it makes your code easier. Okay, because there's always one there. Oh, just the threshold will change. Yeah, that's a good idea. Like I think Nathaniel Bumpo in chat is saying that we could always just like have all 9 in there and just like increase the threshold from 4 to 5, right? Which is smart.
Yeah.
Okay, so these are all this is the coordinates of all the ones that we're counting here. I'm printing it out every time we increment, and this is X and Y. So X is 0 and then Y is 1. It's interesting that I think I might be doing. Am I?
Oh, should we skip? I think I know what we're doing. We're counting the non-paper rolls, aren't we? We're not skipping the non-paper rolls.
Oh, you're absolutely right.
Through.
Yeah,
so we're also including non-paper rolls.
So we need to say if not grid, I, J, continue. Yeah, good call. Mm-hmm. And that's 13. Okay, solid. Okay, Doug. So let me go ahead and grab our actual input. You can see that the actual input for this one is going to be huge. My internet is a little bit slow because I'm streaming so many different things from my computer right now, but we made it. So I'm going to go ahead and put this into the input.
All right.
And then instead of reading out of the example, we'll read out of the actual input. So the function just they called input, and that just like reads from the file called input locally. And then do we have a console log still in here? I'm going to get rid of this just because it might be really big. And then we'll go ahead and run it. 1424. What do you think, Salmon? Do you think we got it right? Okay. So we got that right. So let's go ahead and go on to part 2.
Yeah. Why not?
Yeah.
You got it right. Okay, good.
Nice. Okay, part 2. Now the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklifts might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the elves remove if they kept repeating the process? Start with the same example as above. Here is one way you could remove as many rolls of paper as possible using highlighted @ sign to indicate that a roll of paper is about to be removed, and using X to indicate that a roll of paper was just removed. So the initial state looks like this, and then you have like a highlighted at sign. I don't know if that's coming through. If I blow up the size, you can kind of see which ones are highlighted. This is probably not a very fun website for the colorblind. And it seems like the ones that are highlighted are all the ones that we just actually, that were like from the answer from the previous problem. And then what you do is you remove all the ones that are highlighted, and then you run the algorithm again over the whole grid. And then you do the same thing over and over again until you stop. So this is basically the game of life. I don't know, like that's why I asked about the game of life, because I think this is kind of the same idea, you know.
Yeah.
Okay, cool. So I think I have a pretty good sense of what's going on. So their example, they basically get to 43. Okay, so that's if we run this second our solution to the second problem, which doesn't exist yet, we should get 43 using the example input, right? So the way that we've set up this project is I'm just going to make a copy of the day 04A, which is the first problem of day 4, and then it's going to go into day 04B, which is a new directory. So we basically just have like an exact copy of that previous thing that we did. But now we can solve this new problem, right? So one thing that comes to mind off the top of my head that maybe we can do is we can maybe stuff this into a function so that we can solve this repeatedly, because we're going to have like another loop somewhere that like basically updates the grid continuously, right? So basically, maybe I'll do like function, what I want to call it like a pass or an iteration. Let's just call it a pass. And what it's going to take is, it's going to take one of these grids, which I don't know why I wrote it this way. I think it's actually like, it's easier to write it like this. And then it's going to return the number that got removed. And then it'll also update the grid in place. We can either update it in place or we can return a new grid. Which one do you prefer?
Well, normally I'm a functional programming purist, but in this case,
we can do
just do both in one go.
We can do the purist one. In fact, actually, I think what's better is if we actually return, if we return like the coordinates of the ones that we're going to remove, then we can update the grid, right? We can do something like function update grid, and this is like we take the original one, and then we take the ones to remove. And then we return a new grid. We want to be real functional about it, right? So one pass looks just like this, right? I'm just going to grab this. But the result is going to be an array this time, rather than a number, right? And then we're just, rather than incrementing this, we're just going to do like result.push. Do you like x first and then y, or is it y first and then I think it's actually going to be, it doesn't really matter. We'll just do x and y. And
I like x first.
Okay.
It's x first. Okay. What was the answer to the first part, so I can get into this actual
the answer
advent of code page?
Yes. The answer to okay. You're going to actually have a different. You're actually going to have a different input. So they have like an anti-cheat. So when you log in, they randomize the input. But
that is really annoying. I gotcha. Okay. So I actually have to go do this myself.
No, but you can
read it myself.
You can run it on my computer right now. I can this live share thing. You can actually click into the terminal down here, and then
I gotcha. So I'll just paste in the other.
Yeah, but you just want to do it in day 04A, because that's where like the We've been messing around with this file.
Okay, so I'm gonna go just do that real quick.
Yeah, go for it.
So I can get myself in. Yeah. Okay.
And then if you could just remember to undo the change, just so that we have the original input there, that'd be great.
Yeah. Yeah, so it's make. Wait, I don't have access to your terminal though.
Usually it prompts me. If you click down in the terminal, is there like a request button? Because I usually get a prompt that comes up, and then I basically can grant you the ability to do anything in my terminal, so you can do much harm.
Maybe it did. I requested maybe 10 minutes ago. I requested, but now
That's a bummer.
I'm locked out. I think
Yeah,
you
I
don't
wish there
trust
was a
me.
way I
That's
could
fair.
just like proactively give it to you. Is there a way
Let's
I could do
see.
that?
Well, I mean I pasted in my input, so you could just run it.
Oh, fantastic! So this is your input right now. I'm just gonna run. I'll run it and see if we get a different answer. Try 1478 on your side.
There we go. Yeah, we got it.
Nice.
Yeah, I think that's gonna work.
Okay.
Cool.
Excellent.
I'm in. All right, I get a gold star. Okay. Now I'm gonna just review this real quick.
Yeah. Hang on a second. I think I have too many curlies. Too many curly braces. Yes. Or not. What am I doing wrong here? Some kind of parse error.
Okay, I understand the problem now. Gotcha. Where are we?
I copied our answer from the first problem into this pass function. I shouldn't call it pass. I'm just gonna call it iteration. That's a little bit better.
No, we're using type annotations now. Look at this, fancy. All right.
You know, it actually just helps me not make mistakes. But I think I've got too many curly braces somewhere.
You think? Let's see. Let's track this down. Yeah, is it this guy right here?
No, actually, it's fine. It just doesn't know what X and Y are, right? Y doesn't know what X and Y are. They're just numbers.
Wait, what are X and Y supposed to be? We haven't defined X and Y.
Oh, you know what? It's not X and Y. It's J and
I. You have I and J.
It's J and I. Yeah. Sorry. Okay, so that's one pass.
Yeah. Well, there is an X and Y that we define on 1819, but those are in a different.
Those are the neighbor coordinates.
Those are
I and J is like the center of the 9 thing.
Right.
Someone asked this on Reddit today. The majority said use row and column. Is that like row first then column?
Oh my gosh.
Yeah.
I just think you go XY with an array. This is an interesting topic because I work on games that are all grid based. So this kind of problem I actually am like working on constantly.
Yeah.
And I go XY with a tuple pretty much everywhere.
Yeah, that makes sense.
But you can use an object. So much more verbose though.
Yeah, and I think it's probably on some level less performant. Okay, so that's one iteration. So I think that should basically, like, if we ran iteration over our example input, for example, we should the size of the return value should be 13, right? So as an example, if I called iteration of grid and I printed the length, this should give us 13, right? Yeah. Okay. Cool. So we know that works now. So I think the general structure of the response is going to be something like we're going to iterate infinitely, and then we need to know what the previous, or we're going to have like a grid, and then we're going to do like.
Wait, is the idea we just keep doing this forever until we get a result that's the same as the previous result?
I think the remove list is going to be empty, basically. So we're going to do iteration over the grid.
Yeah, right.
And then if remove list dot length is 0, we're done, right?
Yeah.
But if it's not, then we basically have a result that we increment by the size of the remove list, because that's how many we took away, right?
Yeah.
And then we need to update the grid, right? So it's update grid, remove list, and then we keep going, right? But we have to implement update grid. Which I think shouldn't be too bad, right? I think more or less what we're doing is we're not going
to use recursion. We're using a while loop. It's good. All right.
You would have used recursion?
It is a little bit like I probably would have. Okay, we're writing very similar code to what we already wrote here in update grid, because it kind of needs to do the same calculations as iteration. We could either extract a bunch of utilities, or we could just copy paste it.
I think it should be fine. Probably I think more or less what we're doing is we're going to deep clone. We're going to deep clone the original, right? So what does that look like? It's basically original.map, and then we get a row, and then we're just going to return like a clone of the row. Is that right? And that should be our clone. And then we're going to iterate over all the changes, right? And then we're going to set the false, and then we're going to return the result. Does that look right to you?
Yeah. This is just a clone, right? You know about structured clone?
Is there a deep clone? I mean, you can JSON serialize it and then JSON parse it. Is that what you want? Would you rather do that?
There's a way these days. Structured. This is.
Wait, what is this? Oh my god, you're kind of blowing my mind right now.
Yeah. So that's how you do it now.
All right, I gotta look this up.
It's is new. Newish. Last couple of years. Yeah.
So Node.js has it.
Yeah.
I take it. Oh my god.
Should, yeah.
Okay, cool. We can have nice things in 2025. This is great. All right. So I think 43 was the example answer. Was that right? So if I just run this now, it's 0. So what are we doing wrong? I can breakpoint debug. Do you want to do that?
Sure.
Wouldn't it be more performant to modify the original? Theoretically, yes. I think that's true. But Saman wanted to do the functional thing, which is to not modify. And I don't know if performance is going to be a huge concern, but we'll see. I think if we find that this program takes way too long to run, we can make that optimization. There are some random breakpoints in here.
Being pandered to here.
What's that?
Great. I like that I'm being catered to specifically. That's good.
Yeah. Right. I don't pander. I cater. I think we need to choose our words carefully here. Okay, so there's stuff in the remove list, and it is 13 elements long, so that's what we wanted. And then we add to the result. Oh, I see. I'm just printing the wrong thing. Jesus Christ. Let's try this. 43. Okay, so that's what the example was supposed to be. So if we just run it on the input, we get 8727. So I'm going to go ahead and attempt to submit. It's all big. And that was correct.